Hi there and welcome to the flipped recording for 4.03 Calculating Speed. This is a teacher graded assignment, so you do want to take some notes on completing the lesson. So make sure that you have something to write with and we'll jump right in. So if you notice up here there's some instructions. You're going to create your own car with your materials at home, or you can use something you already have with wheels on it. If you don't have those items, you can just look at the data table that we'll go through in just a little bit. So it's not necessary for you to build or have a car if you don't have one available. You're also going to be creating your own data table to submit along with your assignment. So be sure to include that. Don't skip that portion when you're turning it in. And there is an example in the lesson to show you how to do it. So we'll go ahead and get started on talking about calculating speed. This is our first unit into physics, and the first thing we're studying is calculating speed, looking at a speedometer and an odometer. So those are instruments of speed, and you may have seen those. If you're riding in a car, you've probably seen one before. So when taking a road trip, drivers often check the car's speedometer to see how fast the car is going. The speedometer relates the speed of the car in miles or kilometers per hour. The car's odometer measures the number of miles or kilometers the car has traveled. Each instrument gives the driver important information about speed and distance to infer a number of things about the time and the distance traveled. You'll be designing an experiment to determine the average speed of a toy car. Before beginning your design, take a look at the features of a well-designed experiment. All right, so there's the optional student guide. And let's take a look in the topic review. So when you design an experiment, you guys have learned how to determine motion and how to calculate speed. Remember, speed is the distance divided by time. Now it's your turn to design an experiment and observe and calculate average speed. You'll design an experiment to measure speed using a toy car of some type. You'll also set up a straight track for the car to travel along. So what type of motion will you be illustrating? And this is translational motion. So hopefully you saw that in a previous lesson and you have a definition of that in your notes. Before you begin your design, review the helpful hints for designing your experiment. Refer back to this activity as often as necessary as you proceed with your experimental design. So tips for designing an experiment. Remember, scientists design experiments to prove a point. That point is called a hypothesis. Remember that an if-then statement is used to write a hypothesis. This is important because your worksheet asks you to create a hypothesis and it needs to be in this format. If I do this, then this will be the result. So that's how you'll start and set up your hypothesis. All experiments have an independent variable. Remember, we learned that earlier, and that's what we are testing or changing. And a dependent variable. And this is what we're measuring as a result of from our manipulated variable. So it's what we're measuring as a result of what we changed. So can you identify the independent and dependent variable for your experiment measuring the speed of your car? So in this experiment, if you've read what we're looking at, the independent variable is going to be the wheel size. We're questioning, do bigger wheels move something faster? The dependent variable, so what we're going to be measuring and comparing that to, is the time. So we're measuring the time, that's the dependent variable. What tools would be best to use to measure the independent and dependent variables? So think about, if we're measuring speed and we're measuring time, what would we need? Actually, we're measuring distance, how far the car goes. And so that would be a meter stick or a ruler. If you don't have a meter stick, which most of us don't, all the rulers that we get now from school or at the store are usually inches on one side, centimeters on another. There's 100 centimeters in a meter, so pretty easy to convert that if you need help. And then you could have a stopwatch or a digital watch. All of the phones lately seem to have the timer feature, so you have a lot of things there. And then moving on, you need to be accurate and precise when you're recording your data. Scientists generally repeat the steps of a procedure 3 times to be sure of the results. So if you'll notice, you need to do each step 3 times. So if we have a trial, it's going to ask for your data on a data table, and I will be looking for the results that you did your trial of each one 3 times. So be sure to have those in your data table. And what is the scientific name for each attempt? We know that that is called a trial. A good experiment contains 3 trials. And then remember, any measured results are always averaged. So you need to have an average in your data table as well. So let's see. How do you think scientists remember all the measurements and observations they make? Scientists write those down in a notebook, and then they create a data table. So it gives you information. Remember, you need to have a title column for each trial. You need to have a trial number, the time, and the distance measurement. So if it's measured in time, you need to have seconds after it. When you're measuring distance, you need to have m for meters after it. Scientists explained, I missed one. If the title of your experiment is calculating speed, what formula will you use? The answer's in here for each trial. You need to look at speed equals distance over time. And to form a conclusion at the end, when it's wanting your average speed so that you can give some results, you're also going to use average distance over average time. And then scientists explain what happened during an experiment. How do they come up with this explanation? Scientists analyze and evaluate the data collected, and they make inferences and predict trends based on their data. This explanation is called a conclusion. A conclusion should always refer back to the original hypothesis. It should include a statement about whether or not the hypothesis was proved. So make sure your conclusion says something about my hypothesis was correct or incorrect because, and then your data should support that. Okay, as we move on, again, it gives you the materials. You need a straight, flat surface. That can be a table or a floor, a stopwatch, or and a metric tape measure, ruler, or meter stick. Gives you some optional things that you can do here. You can build your own type of something that rolls. Gives you suggestion of CDs. Anything that rolls will work. Dowels or straws to connect those. So you're making wheels, or maybe you have something at your house that has wheels on it. And so a couple of different things. It says, how can you calculate the average speed of a vehicle on a track? Think about how you would design an experiment using these materials to figure out how to answer this question. For this experiment, you can build your own vehicles using the materials suggested here, but you can also use the materials you have on hand. So you can use toy cars instead if you needed to. But you're basically putting a track together and trying to test the question, does the wheel size affect the distance a car goes in a certain amount of time? So this is an important table. It helps you get everything set up. This is what your data table will look like. If your variables, if you don't have a CD cart, right? If you made something else or you're using a toy, then make sure you change those titles. But you're going to collect data from the experiment that's necessary to prove or disprove your hypothesis. What should be included? So Tyler, in this case, has built 2 vehicles, one using large CDs and one using mini CDs to prove his hypothesis. He's got to take measurements for both. and he's labeled the 2 columns in his data table to reflect those 2 items. The purpose of the experiment is to calculate speed. So what variables are required for calculating speed? Remember, we talked about the formula already. It is distance over time. According to the procedure, what will be measured? So if we read through that, remember that we are measuring the time and distance. They're going to be measured for all 3 trials. The distance remains the same, so this requires only 1 line. The time will be measured 3 times for each vehicle, so Tyler has labeled 3 rows with the trial numbers. Okay, so the distance on your track doesn't change. All right, and according to the procedure, what will be calculated? You can look up there and also see the procedure calls for an average time of the 3 trials. This is calculated, and the results are recorded in the row labeled average time. Average speed is calculated for each vehicle by dividing the distance measurement by the average time for each vehicle. A row has been created for this information. So this tells you exactly what you're calculating. So as we move on, remember, if you don't like to click through all of these little squares, you can open up the document. But this just gives us gather the materials, make sure you have 2 vehicles or something similar. And then it goes through the 9 steps of what you need to do to create or go through and do the experiment. So remember, print out the steps if you're going to be doing that and you want to take those. I think it's easier to have a piece of paper to take with me to read through. So up to you how you do that. This screen is important if you're not able to do the actual car experiment on your own. So now that you've recorded your data, it's time to analyze it. In this case, the first step is to do some calculations. So if you're not able to do this lab on your own, you need to borrow Tyler's data. So you would copy these into your data table that you've created. If you want to draw it in on your worksheet, that's fine. Then you can just scan that in. You will need to average those yourself. It doesn't give you the answer there. And then you need to do the average speed. Remember, speed is distance over time. So what was the average time for Tyler's big CD cart? It shows you the average time. It adds all of those up for the 3 trials, and it gives you an answer of 4.16 seconds. And then calculate the average speed. Remember, the worksheet says show your math work. The directions are in there. So even if you're using Tyler's information, you need to have the work in there to show how you got it. So calculate the average speed. This is this little delta symbol just means a change in distance divided by a change in time. So you have 2 meters divided by 4.16 seconds, which equals 0.48 meters per second. Speed is always measured in meters per second. All right, so as we move on, your data chart probably looks something like this. If you did not use Tyler's, it will look very similar. There are lesson questions that go along with this, so make sure you click here and print out the worksheet to answer the questions. Please don't leave off your hypothesis. It's at the very top, and don't leave off your data table. That's very important too. All right, and then once you get to this point, this is the worksheet again if you need it, and then you just upload your assignment here. If you have questions, come see me in Help Lab. But for now, if you have questions, like I said, see me in Help Lab and check out the next Flip follow-up session. Thanks for watching and have a great day.